Good day, this is Jim Pytel from Columbia Gorge Community College, Renewable Energy Technology Program. This is RIT 120 Hydraulics. First and foremost, for your success in this class, and for that matter, any course in the RIT program, you need to come to the unconditional realization that this is not a math class. This is an applied mathematics class about hydraulics. So we'll be making use of basic mathematic techniques, which I expect you to know to discuss hydraulics. That being said, I am going to review some of the basic math we do. If at any time you feel that you're incapable or unqualified to do this, I urge you to seek help instantly or turn back now, because again, we are going to be using this on a daily basis. So one of the topics I'd like to discuss right from the beginning is basically calculating area and volume. And the shape that we calculate area and volume of a lot is, in respect to area, a circle, and volume, a cylinder. The reason why is because hydraulic cylinders, as you see right here, here's an external of a hydraulic cylinder, here's an internal. Well, they are circular in nature, the piston faces, and the barrels are cylindrical in nature. So we find ourselves calculating area and volume of circles and cylinders quite a lot. So let's discuss what area is. So most of you guys know if you start at one point, go a foot in that direction, go a foot in that direction, what you get, if that's 1 foot, think of the units. Units of foot is a length, 1 foot depth. What you get is 1 square foot, which represents that area. Most commonly used terms in an apartment, you have a 400 square foot apartment, you have a 600 square foot apartment, buildings, fields, okay? So there's a number of units for that, for area. Acres is a good example. Square foot, square meters if you're using the SI system. Typically, we are going to be using areas of square inches. So a square inch, go 1 inch that way, go 1 inch that way. What this represents is 1 inch squared. So that 2 up there is key to it, 1 inch squared. So our circle, though, is not square in nature, it's circular. So there's a couple formulas you can use to figure out how much area a circle has. So area of a circle is this magic number pi, r squared, or it's pi over 4 d squared, or it's 0.8754 d squared. And I do not care which formula you remember, but I wouldn't recommend using this one because it's easier to forget it's 0.7854. You could substitute an incorrect number. The number I like to use, the formula I like to use is this one, pi over 4 d squared. What is d? D is this number. It's the distance from edge to edge passing through the center of a circle. Radius, very similar, but it's from the center to the edge. So it stands to conjecture 1 diameter is 2r, or half of the diameter is a radius. So if you remember this one right here, you get this one as a bonus formula, because if r is d divided by 2, what happens when you square d divided by 2? Because you're squaring the 2 below. Pi over 4 d squared. Makes no difference to me. Just remember one of these guys. Typically, I remember, again, this one because typically cylinders are sized according to their diameter. So, for example, I give you a circle 1 inch in diameter. Double hash marks typically means an inch. What is the area? So area of a circle, 1 inch diameter. Pi over 4, 1 inch squared. It's 0.7854, because again, you're getting this formula as a bonus. 1 squared is 1, so it's 0.7854. And what is our units? Inches squared. Always think in terms of units. Okay. What's the area? Here's another example problem. What's the area of a circle that has a diameter of 2 3/8 of an inch? So 2 3/8 of an inch can be written in decimal form as 2.375 inches. So pi over 4, 2.375 squared. What do you get as a result? You should be getting 4.430 inches squared. Okay, so this is not limited to the English system, which is inches and feet. We could easily use the SI system, and a typically quasi-SI unit for length in terms of cylinders is the centimeter. So 1 centimeter. So let's say we have a diameter, and this guy is 1.5 centimeters. What's the area of this circle in terms of square centimeters? So still the same formula, pi over 4 d squared. What you should get right there is 1.767 centimeters squared, because again, we're sticking with the same units. So now this brings us to another thing we need to discuss is unit conversion. Do you always want to be in inches? Do you always want to be in centimeters? The answer is no. You have to find a way to convert them. So I must direct you to the internet. Perhaps you've heard of it. There are numerous online calculation and conversions tools available, but you don't always have access to the internet. So here's an easy way to do it manually. And this is how I think of it. You can always multiply something by 1 and not change it. Let's just stick to a very, very simple example. 6 inches. I want to convert that to feet. You already know it's a half a foot, but bear with me. You can always multiply something by 1. What is the 1 that you want to multiply it by? Think of the unit you want on top, the unit you don't want on the bottom. Because when you multiply 6 inches times 1 in the format of 1 foot equals 12 divided by 12 inches, which we know is 1, the inches cross out, and you're left with 6 divided by 12 feet, which is 0.5 feet. Very simple. So not so simple is this conversion here. Well, it's still simple. So we're asked to, okay, let's say we have a diameter of 1.5 centimeters. We want to determine the area of that circle in square inches. One way to do it is, if a diameter of 1.5 centimeters, we can convert this directly to inches. And again, how do we do it? Multiply by 1. What's the 1? 1 inch. How many centimeters in 1 inch? 2.54 centimeters. What I'm getting rid of is on the bottom. What I want to keep is on top. So 1.5 divided by 2.54, 0.591 inches. What is the area of something 0.591 inches? The same formula we've used before. Pi over 4 d squared, and in this particular case, our diameter is 0.591 inches. Should give us a value 1.096 inches squared, which is an incorrect answer. So figure out where I made the error here. That sounds too big. Okay, so if 1.767 centimeters squared does not equal 1.096 inches squared, the error was right here. Forgot to do that divided by 4. So the actual answer is going to be 0.274 inches squared. So it helps to always check your work as you're going through this thing and figure out where you made the error. That's actually the most important thing, so you can basically never make that same error again. So there's another way to do this, is basically what we did here was we converted the diameter, our earlier diameter in centimeters, to inches and then determine the area. Another way is to do this calculation, get your area in square centimeters, and then just convert it from there. Again, using that same, you can always multiply by 1 trick. So what is something, let's say we're looking for square inches. If 1 inch equals 2.54 centimeters, how many square centimeters is 1 square inch? Well, 2.54 times 2.54 gives us our conversion of 6.452 centimeters squared per square inch. So we could just as easily divide, 1.767 centimeters squared, convert that directly to inches squared using this conversion factor. And ideally, we should be getting the same answer. So what's this? What do we want to get rid of? We want to get rid of centimeters squared. 6.452 centimeters squared is equal to 1 inch squared. These guys cross out. And what do you get for your answer? 0.274 inches squared. Makes sense. Okay, we've used this formula, pi over 4d squared, over and over and over again. Someone gives you the diameter, and you could easily find the area. So I'm going to give you a couple example problems here. Let's see if you can do it. Okay, so here's our example problems. First one, diameter, 2.5 inches, find the area in inches squared. Go ahead and pause the recording if you feel you're capable of doing this. Same thing for 2 and 3. You got a radius, notice the dramatic pause, radius 2.25 inches, find area in inches squared. And now 3, I'm giving you the area. I want you to find the D in units of inches. So again, if you feel confident to do this, go ahead, pause the recording, take a stab at it, and I'll be here waiting for you to come back and show you the correct answers. Okay, hopefully you took a stab at it and you're going to get the same answers that we get right here. So, diameter, 2.5 inches. Find area in inches squared. So, area equals pi over 4 d squared, pi over 4, 2.5, 2.5 squared is going to give us a value 4.909 inches squared. Okay, radius 2.25 inches. Find area in inches squared. Is this the correct formula to use? No, it is not, because we are given the radius. Okay? If we wanted to use that formula, how do we do it? Diameter is equal to 2 radiuses, because if we remember our circle up here, diameter goes from edge to edge. Okay? So I have to double it. 2.25, 4.5 inches. Or I could use the formula pi r squared. Whichever one you want to. You should be getting a value of 15.904 inches squared for our area. Okay? Last one. Problem 3 is giving you the area. And now it's asking you to find D in inches. So this is one of the other concepts that is critical to your understanding of the applied math that we're going to be doing in hydraulics. You have to figure out basic algebra, how to get something, an unknown, by itself to solve for it. So the formula that we typically have been using, pi over 4 d squared. Okay, we're given this. This is the unknown. So How you do it, put the knowns on one side and the unknowns on the other. Now I could just easily substitute that number in there, but I don't recommend doing that. Keep everything in symbolic terms so you can manipulate it. So this is how you do it. Multiply by 4 both sides. You haven't changed it at all. This 4 cancels out with that 4. We're left with that. Divide by pi both sides. These pi's cancel out. And we're left with that. How do you get rid of a d squared? Square root it. Square root it. What are you left with? D. Now is the time to put that number in there. You should be getting a value of 4.125 inches, or in terms of 1/8 inches, 4 1/8 of an inch. Okay, so example problem 3 highlights, again, basic algebra. So if you're familiar with Ohm's Law, perhaps you've heard of this. V is equal to IR. One could easily put this 3-variable formula in something like this. V, I, R. You want to know V? Multiply I and R. You want to know I? Divide voltage by resistance. You want to know R? Divide voltage by current. Very similar to Pascal's law, which we'll be going over here very shortly, where force in terms of pounds force is equal to pressure in units of pounds per inch squared times area in terms of inches squared. We could just as easily take our triangle FPA. To find force, multiply pressure times area. To find pressure, divide force by area. To find area, divide force by pressure. This makes sense in the units too. So pounds is equal to pounds per square inch times inch squared. Of course it does. These guys cross out and you're left with pounds on both sides. So be aware the unit for pressure, which we'll be discussing shortly, pounds per square inch, is often written as PSI, pounds per square inch. That's what it means. If it helps you to stick in the pounds per square inch, go ahead, by all means use that. Okay, so the last topic I'd like to discuss in this portion of the lecture is calculation of volume. Okay, if area is two-dimensional space, flat objects, flat squares, flat circles, flat triangles, whatever, and you get units in inches squared, and volume is 3 dimensions, you should probably get units in inches cubed, or length units cubed. If you're going to use cubic centimeters, it's be cubic. If you're going to use centimeters, it's cubic centimeters. If you're going to use meters, it's cubic meters. Okay, so visualizing what volume is, go 1 inch that way, go 1 inch that way, and go up 1 inch. You've got a cube, which you could fill up with water or rocks or bumblebees, whatever you want to. It's a cubic inch. It holds something. How much does it hold? Well, it holds a cubic inch. Okay, so to calculate the volume of something, let's say it's a box. We've got our three dimensions: length, width, and height. Volume of a box-shaped structure: length times width times height. Look at the shape of our cylinder. It's not box-shaped, appropriately enough, it's cylindrical shaped. How do you calculate the volume of a cylindrical structure? Okay, first off, before we answer that question, look at this. What does this represent here, that one face? Well, it represents area. Translated in that direction for however long that box is, that's a three dimension. So think of a cylinder as a circular area translated the entire distance of its height. That is the volume of a cylinder. So the volume of a cylinder and the volume of our box is really kind of the same thing, where that length times width, in this particular example here, I'll just redo the units so everything's the same. Let's pretend that's length, that's width, and here's height. Let's say we got the box upside down. Length times width is our area of our flat plane times the height. Same thing with our cylinder. Area of our circle times height. One could easily just do this all in one step. Pi over 4 d squared times h. What is my volume of my cylinder? Well, it's my area times my height, or it's pi over 4 d squared times h, where d is the distance from edge to edge of our top surface here. Okay, so let's go ahead and just do an example problem here. Let's say we've got a cylinder. It's got a diameter of 4 inches. It's got a height of 6 inches. What is the volume of this cylinder in cubic inches? So, pi over 4 d squared times height, pi over 4. My diameter is 4. My height is 6. Should give us an answer of 75.398 inches cubed. Okay, so here's another example problem. Here's another set here. Find volume in cubic inches of this guy. Three-inch diameter, 8 inches tall. And number 2, let's say 3 7/8. Oops. Inch diameter, the height of 20 inches. So go ahead, I'm encouraging you to pause the tape if you feel confident doing this. We'll see if you get the same answers that we do. So go ahead, set yourself up. Volume equals pi over 4, 3 squared times 8. You don't need to do all these intermediary steps because you've got your calculator. Should give you 56.549, I believe. 49 inches cubed. Second example, 3 7/8. Pi over 4, 3 7/8 squared times a height of 20. Do you think this is going to be bigger, more volume than the last one? Of course it is. Well, it's 20 inches higher. Not only is it 20 inches higher, it's got a larger diameter. So that answer should be 235.865 cubic inches. Okay, so now let us discuss another unit of volume. Okay, is cubic inches the most common unit of volume? No, it's not. Typically, things are measured in gallons. So why are they measured in gallons? It's just an easy concept to understand. 1 gallon. It's like that thing of milk inside your refrigerator. It's an easily understandable unit of measurement. So what is a gallon in terms of cubic inches? Again, this is our multiplication by 1. 1 gallon is equal to 231 cubic inches, inches cubed. So if I want to convert any of these ones into gallons now, first example had 75.398 cubic inches. I can multiply that, 398 times 1, so 1 gallon divided by 231 inches cubed. It's going to give me a value of 0.326 gallons, roughly of a third of a gallon. So 56.49 could be more or less gallons. Well, less because it's less cubic inches. So 56.549 divided by 231 cubic inches. So it's going to be 0.245 gallons. So our last one here, it's 235 cubic inches. And if there's 231 cubic inches per gallon, would it be more or less than 1? Ever so slightly more. So 235.865 divided by 231, 1.02 gallons. Our suspicion was correct. So always give yourself a reality check there. Okay, you can do this in reverse. Do the same unit conversion in reverse. I give you 6 gallons of something. How many cubic inches is it? Well, multiply by 1. Is that the format that we want? No, because we want to get rid of gallons and keep inches. So put the gallons at the bottom, 1 gallon, 231 cubic inches. So 6 times 231 is 1,386 cubic inches because gallons cross out. So by now, you should be extremely familiar with calculating area, doing unit conversion, doing basic algebra, doing volume calculations. And now using all these same techniques, I'm going to throw a curve at you. A hydraulic cylinder, again, is cylindrical in shape. But now imagine a piston that fits inside that barrel. Has this thing sticking out of it. And that's called a rod. Okay? If I flip this rod over, I have a piston face, or a cap end, and then I go ahead and rotate it back this direction. You can see our rod end. This is what's known as the rod end or rod face. This is the rod itself. Question to you, do the cap and rod face have the same area? No, they don't. And why don't they? The cap end, what is the area of that cylinder? Well, give it a diameter. You can find the area. What is the area of the rod face? Depends on two things. Well, what do they depend on? The diameter of the cap end face. Let's draw this in bigger. And what is removed from it is the diameter of the rod, the area of the rod, excuse me. So D1, D2, where D1 represents our cap and D2 represents the diameter of our rod. So we have to calculate this annular area, annular or ring-shaped or donut-shaped, whatever you want to call it, area. That's the area that we're interested in, the rod face. So are the areas the same on the cap end and rod end of a cylinder? No, they're not. Which has more? The cap end, because it doesn't have the rod taking away area. Which has less? Well, obviously the rod face, because it has the rod taking away area. So what is the volume, excuse me, what is the area of a rod face with, let's say, piston diameter of 3 inches and a rod diameter of, let's say, 1 inch? And to make this things simple, I'm going to say dr, d cap, okay? So all it is, just think about this way, it's two superimposed circles. Area of the cap minus area of the rod is equal to our area of our rod end, okay? So find the area for the rod, find the area for the cap, and just subtract them. What is the area? Pi over 4, 3 squared, minus pi over 4, 1 squared, should give us our rod area. So that's 7.069 inches squared minus 0.7854 inches squared. Going to give us a value of 6.284 inches squared. Okay, so it shouldn't be that hard of a concept, but you just have to visualize this thing here. Okay, I'm going to give you another example problem. Let's say our cap face is also 3 inches diameter. Then you've got a rod, let's say 1 5/8 of an inch. What is the ring-shaped area of the rod end? So set up the formulas. Area of the rod end equals area of the cap minus area of the rod. Area of the cap, we already figured that one out, 7.069 inches squared, minus pi over 4, 1 5/8 squared. Should give you an answer of 4.995 inches squared, which makes perfect sense because if we had a 3-inch cap face there before, diameter, and we had a 1-inch rod, and that space, which we, from our previous example problem, was 6.284 inches squared. Now we've kept the cap face the same. We've increased the rod diameter to 1 5/8. That means the rod area should decrease, which it does, down to 4.995 inches squared. Okay, so it always makes sense to visually compare these things. Did I go in the right direction? Okay, so the last curveball I'm going to throw at you guys. What is the volume of a cylinder when the rod is all the way retracted. Just think of this as the rod is a solid object, which it is, and try to fill this thing up with water, or in our case, hydraulic oil. How much water would fill up in there? Will it be the volume of the cylinder, the full cylinder, minus the volume occupied by the rod, which would equal this tubular shape right there, where this is object filled in? Okay, so the volume of a cylinder when the rod is fully retracted, there's something in the way. Sounds like volume of the cylinder minus volume of the rod is going to give us our retracted volume. So let's say, okay, we're going to go ahead and let's say our cylinder is, again, 20 inches high. And we're going to use this example right here where it's 3 inches face. With an 1 5/8 rod. So, whoops. Volume of our first cylinder is our area times our height minus area 2, or area R, I should say, area of the rod times the height of the rod. So what was that first area? 7.069 inches squared. 7.069 inches squared. How high is that? It's 20 inches. Minus the area of our rod. What was the area of our rod? It's an 1 5/8. Well, the diameter, so pi over 4. 1 5/8 squared. What is the height of the rod? Well, it's all the way retracted. It's the same height as the height of our cylinder. Times 20. So we get 141.38 cubic inches, the volume of our full cylinder, minus 41.48 cubic inches, which is the volume of our rod, gives us roughly 99.9 cubic inches. Okay, so some of you guys may see a shortcut already. Well, if you're saying this volume of a cylinder is area times its height, didn't we already calculate its area right here in square inches of 4.95995 inches squared? Yes, you're absolutely correct. So we could easily do area of our ring times our height, 4.995 times our height, 99.9 inches cubed. Okay, so volume of a cylinder with a cylinder inside. Not that hard of a concept to get here once you visualize it. Okay, so last here, how many gallons is inside our 99.9 cubic inches? So 99.9 cubic inches multiplied by times 1 gallon, divided by 231 inches cubed. What do you get here? So 99.9 divided by 231.432 gallons. Okay,